We're using the sketch method to draw the graph of a straight line. And when you do that, it's rather like being a detective. What you do is you find out clues about what the graph looks like, and then you use those clues to draw the line. Now the first two clues are easy to find, because if the graph is presented in the form y equals ax plus b, then the number a represents the gradient of the line, and the number b at the end represents the y-intercept. You can see those straight off. So two clues are easy to find. Gradient, in this case, equals 2. Now if I know it's got a gradient of 2, I know that the graph slopes upwards from left to right. So already I'm getting a bit of a picture about what this graph looks like. The y-intercept of the line I can find by that number at the end of the equation. So this one equals 5. It cuts the y-axis at 5. The last thing that I might want to find is the x-intercept of the line. And the x-intercept I find by making y equal to 0. At the point where the graph cuts through the x-intercept, its y-coordinate is 0. So if I make y equal to 0, I'm going to put 0 instead of y. 0 equals 2x plus 5. If I do that and now solve this equation, find the value of x that makes this equation work, I will have found the x-intercept. So the first thing you do is you put y equals 0, and then you solve the equation. That's how you find the x-intercept. Okay, we've made y equal to 0. Now solve the equation. Take 5 from both sides, minus 5 is equal to 2x. Now divide both sides by 2. Negative 5 over 2 equals x. You could do that on your calculator if you wanted to. And when you get x is equal to negative 2.5. So now I know the gradient, which way it's sloping. I know the y-intercept and the x-intercept. That's enough clues that I can use to draw the graph. Generally, I like to see the graphs a little bit bigger than the space you've got available here. But we've got to go with what we've got. So let's draw my axes. I've got a y-intercept at 5 and an x-intercept at negative 2.5. And I know that it's got the form of a straight line, and I know it slopes upwards from left to right. So this graph is going to look like this. Let's have a go at another one. The first two clues are easy. The gradient and the y-intercept. The gradient is given by the number in front of the x. It's called the coefficient of x. In this case, the coefficient is minus 4. This graph has got a gradient of minus 4. It means it's sloping downwards as I look at it from left to right. The y-intercept of the graph is that number at the end. So the y-intercept equals 8, and the x-intercept. To find the x-intercept, you put y equal to 0. So you get this equation, and we're going to make y equal to 0. 0 equals negative 4x plus 8. Now solve the equation. Shuffle it round until you get x equals something, or something equals x. And in this case, I would start by taking away 8 from both sides. Minus 8 equals minus 4x. And now divide both sides by minus 4. Negative 8, I'll write it like this, negative 8 divided by minus 4 equals x. Do it on your calculator if you have to, but x equals positive 2. Okay, this one's got a negative gradient. It slopes downwards from left to right. It's got a y-intercept at 8 and an x-intercept at 2. When you do these, you don't have to measure everything out. You don't have to really do it to a particular scale and graph paper or anything like that. All we have to do is make care that we have labelled our x and y axes, and we have included these numbers on here appropriately. Got a couple more to do. So this one's got a gradient of -3, slopes downwards as I see it from left to right. It's got a y-intercept, cuts through the y-axis at 6, and it's got an x-intercept. To find the x-intercept, we make y equal to 0 in the original equation, and then we solve the equation for x. We move it round until we get x equals something. Take 6 from both sides of the equation, then divide both sides by -3. -6 divided by -3 equals x. X equals 2. Put that information onto the graph. A y-intercept at 6, a negative slope, and an x-intercept at 2. And we've got one more here. So y equals 3x. Notice that we haven't got any number on the end, or if you like, it's +0 on the end. So this one has got a gradient. Number in front of the x is 3. It's got a y-intercept. Number at the end is 0. And if you want to find the x-intercept, we make y equal to 0. 0 equals 3x. Then to get x by itself, divide both sides by 3. 0 divided by 3 equals x. 0 divided by 3 equals 0. X equals 0. So, to draw its graph, it's got a gradient of 3, that's a positive gradient, it slopes upwards from left to right. It's got a y-intercept at 0 and an x-intercept at 0. So the graph is going to look something like this. Okay, that's a bit of a special case, that graph, the way it goes through 0, 0. Look at its equation, y equals 3x. That sort of thing's going to happen whenever you've just got a y equals 3x plus 0. It's going to have a y-intercept at 0, and so it's also going to have an x-intercept at 0. Bit of a special case. Now I've got some special cases at the bottom here. That's one of them, y equals 3x. And it's a graph that looks something like this. Y equals 3x. Now, y equals any number x will look like that as long as x is a positive number. If y is a negative number, like y equals -5x, it's sloping downwards from left to right. Same sort of thing, sloping downwards from x to right. It's still got a y-intercept of 0, so it's got to go through that point 0, 0. We call that the origin. It goes through the origin of the point 0, 0. The difference between any graph that looks like y equals 3x or y equals 2x or y equals 55x is the gradient. The bigger the gradient, the steeper the graph is sloping up. So you could have one which kind of went through here with a small number for the gradient, or one which is going through here with a very steep value for the gradient. What about the graph y equals x? Well, that really means y equals 1x. So it's just another member of this family. In fact, if y equals 1x, the special thing about that is the gradient of it is 45 degrees if your x and y axes are done to the same scale. Two more graphs which are worth remembering are these two here, y equals 4. If you like, I suppose you could write that as being y equals 0x plus 4. It's got a gradient of 0. A gradient of 0 means it's going straight along, and it's got a y-intercept of 4. So this line is going, it's a horizontal line which goes through at 4. If you like, the equation says y equals 4. It doesn't matter what x is. Y always equals 4. So for any x value you like, it's independent of x, for any x value y is equal to 4. And the line x equals minus 2 is very similar. It just means x is always equal to minus 2. It doesn't matter what y equals. Y is not part of that equation. X always equals minus 2. And so what we'll get is a vertical line of points going through where x always takes the value minus 2. It's worth remembering these special cases because they will come up in different questions.